Fascynująca Ziemia.
I will show today geophysical contribution in Egyptian historical archaeology discoveries. My name is Eslam Roshdy from Egypt. I'm a geophysicist specialized in data analysis, seismic. I worked as assistant lecturer at Geophysics Department, Faculty of Science, Cairo University. I worked in many projects for archaeology prospecting and near-surface imaging, and I am currently PhD student in Geophysical Imaging Department at Institute of Geophysics, Polish Academy of Science. I will start with introduction about the land of pharaohs and 10 main features in Egypt, and then I will show some geophysical principles regarding ground penetrating radar methods, GPR, electrical resistivity methods, ERT, and seismic method, reflection and refraction. And after that, I will show some geophysical case study from Egypt to show and prove the contribution of geophysics in the archaeology prospecting. Egypt is located in North Africa. It's surrounded from the Mediterranean Sea from the north, Sudan from the south, Red Sea from the east, and Libya from the west. The name Egypt comes from the ancient Greek name for the country Egyptus. The official language of Egypt is Arabic. Cairo is the capital city of Egypt, one of the largest cities in Africa and the Middle East. Egypt is one of Africa's largest oil and gas producers. Egypt is also known for its high-quality Egyptian cotton. I would like to share this video to give some information about ancient Egypt in 2 minutes.
The ancient Egyptian civilization existed along the Nile River in northern Africa for 3,000 years. During this time, kings, known as pharaohs, controlled the country and were considered to be half-gods. The first pharaohs appeared around 3100 BC and united the two halves of the kingdom, known as Upper and Lower Egypt. The first significant period of Egyptian history was known as the Old Kingdom, lasting from 2700 to 2200 BC, and the famous pyramids of Giza were built during this time. However, by the end of this period, the pharaohs lost control, and Egypt descended into civil war, known as the First Intermediate Period. Around 2055 BC, the pharaohs once again reunited Egypt, beginning the Middle Kingdom period. It was during this era that Egypt expanded militarily and conquered Nubia because of its rich gold supply. However, the Middle Kingdom also collapsed into civil war in 1786 BC, called the Second Intermediate Period. During this time, a line of foreign rulers known as the Hyksos took control of northern Egypt. Then, around 1567 BC, Egypt was unified again, and the Hyksos were driven out, beginning the New Kingdom period. This was the time when Egypt was most powerful and influential, as warrior kings, like Thutmose III and Ramses II, expanded Egypt's borders beyond anything it had experienced before. It was during the New Kingdom that pharaohs built tombs in the Valley of the Kings, including the famous Tutankhamun. Once more, Egypt collapsed into its Third Intermediate Period, around 1085 BC, and the region struggled with constant invasions by the Assyrians, Babylonians, and the Persians. From the late 4th century BC, Egypt finally lost its independence forever. It was taken over by Alexander the Great, and, later, the last pharaoh, Cleopatra VII, would finally lose it to the Roman Emperor Augustus in 31 BC.
Maybe after this video we understand why Egypt is the land of pharaohs. I will present the most important 10 main features in Egypt. If you are interested to visit Egypt later, you should take this feature in your consideration. Number 1, Nile River is the longest river in the world, stretching over 6,650 kilometers. The main water source in Egypt is the Nile River. The primary sources of the Nile are the Blue Nile and White Nile, which converge in Sudan before flowing into Egypt. Lower and Upper Egypt refer to the two main regions of ancient Egypt, which were divided based on the flow of the Nile River. Upper Egypt means upstream from starting the flow of the Nile River, and Lower Egypt means downstream toward to Delta and Mediterranean coast. Nile River can be represented as an important tourist attraction in Egypt. Number 2, pyramids and Sphinx in Giza are the most iconic symbol of ancient Egypt. The pyramids were constructed as monumental tombs for the pharaohs Khufu, Khafra, and Menkaure. This is the name of pharaohs. The Sphinx is a huge limestone statue with the body of lion and head of human. The pyramids and Sphinx are major tourist attraction, drawing millions of visitors from around the world each year. Visitors can explore the pyramids' interiors, view the Sphinx, and learn about ancient Egyptian history and Egyptian culture. Number 3, Temple of Abu Simbel is one of the most nice ancient sites in Egypt. It's a massive temple in southwest of Aswan, near the border with Sudan on the western bank of Lake Nasser. This temple was created in the period of King Ramses II in the 13th century BC. Today, Abu Simbel is a UNESCO World Heritage Site and one of the Egyptian top tourist attractions. Visitors can marvel at the massive statues and complex hieroglyphics that show ancient Egyptian culture. Number 4, High Dam. The Aswan High Dam is one of the most significant engineering projects in Egypt. Aswan Dam is one of the largest artificial water reservoirs in the world. The primary purposes of the Aswan High Dam are flood control, irrigation, and electricity generation. By regulating the flow of the Nile River, the dam helps to prevent destructive floods. The dam also generates electricity through its hydroelectric power station, helping to meet the country's energy needs. Number 5, Hatshepsut Temple. Hatshepsut Temple is located in Luxor on the west bank of the Nile River, one of the ancient Egyptian most remarkable rulers for Queen Hatshepsut. This temple has unique design features, 3-step levels, and it's built during the 15th century BC. Number 6, Karnak Temple. It's located on the east bank on the Nile River in Luxor. It's one of the largest and most impressive temple complexes in the world. Can be represented as open-air museum and date back over 4,000 years. Karnak Temple serves as the religious center of ancient Egypt, Alexandria Library, and Mediterranean coast. Alexandria Library is the biggest library in Egypt and stands as symbol of knowledge, culture, and innovation for all researchers and people in Egypt. Mediterranean coast represents as a destination for travelers seeking sun, sea, and exploration. Visitors can relax on the shore, enjoy with the sun and panoramic views of the Mediterranean Sea. Number 8, Wadi al-Hitan or Well Valley in Western Desert. Wadi al-Hitan is a UNESCO World Heritage Site located in the Western Desert. It can be represented as a paleontological site. The landscape of Wadi al-Hitan is characterized by desert plains, sandy dunes, and rocky outcrops. The fossils found in Wadi al-Hitan provide valuable insights into the evolution of worlds and the transition from land to marine environment. This fossil date back to Eocene period, approximately 37 to 40 million years ago. Number 9, Jabal Santa Catherine is the highest mountain in Egypt. It's located in the South Sinai and it stands as elevation of approximately 2,629 meters above sea level. Sharm el-Sheikh beach is very nice place. and you can participate diving and seeing the coral reef. Number 10, and the last one, Egyptian Museum in Cairo is one of the most prominent culture institutions in Egypt. It's contains over 120,000 items, including statues and the treasure of Tutankhamun, one of the most famous pharaohs of ancient Egypt. I would like to play this video to enjoy more about Egypt. Talked about Egypt now, and I will move to second part, geophysical principle. Geophysics is the application of the principle of physics to study the Earth. Geophysics can be passive and active methods. Passive methods mean natural measurements, and active methods mean active measurements. And main application for geophysics: regional geological studies, hydrocarbon exploration, mineral exploration, engineering and environmental investigation, hydrological investigation, cave detection, archaeological prospecting. I will start by talking about ground penetrating radar method, GPR. Radar system consists of signal generator, one or more transmitting and receiving antenna, its main device, depending on the system and deployment methods, and a control unit for managing the signal generation and recording. And this picture from the field by using the device of GPR, and this final result for GPR showing there is faults here. And second method, electrical resistivity methods, ERT. Resistivity is the property of material that resists the flow of electrical current. Conductivity is the opposite of resistivity. The measured resistivity of a formation depends on the amount of water present, pore pressure geometry, fluid chemical composition. ERT acquisition as recording consists of electrodes set on the surface with certain distance. This distance between electrodes defines the depth of penetration of current field. These electrodes mean array, and there is three main arrays in ERT: Wiener, Schlumberger, and dipole array. And this figure from field for acquisition ERT, and this device and these electrodes. Seismic methods, third methods consist of reflection and refraction. It depends on sending sound wave, seismic wave in the earth with certain physical parameters in the earth, and receiver to receives the response of this wave. There is two main of waves are considered in seismic exploration: body wave and surface wave. Body wave means the wave is entered within the subsurface, and surface wave is traveled along the surface of the earth. Seismic simply consists of shot and receiver. Shot for sending seismic wave in the subsurface. Some of this energy reflected to the receiver and the rest of this energy reflected down. So we can define two laws for seismic: law of reflection, law of refraction. Law of reflections mean incidence angle equal reflection angle, and refraction angle is Snell's law. Seismic is dependently consists of three stages: acquisition, recording of seismic, like to take source and receiver in the field and record all signals: reflected, direct, airwave, refracted, multiples, all types of signals. And this signal need to be filtered, remove noise, enhance signal, which means processing to enhance the image, and after that interpretation for the seismic section to show what is the subsurface as a structure, faults, layers. And this video will show simply what's the geophysics.
An introduction to geophysics. Have you ever wondered what lies beneath the surface of the Earth's crust? That's where geophysics comes in. Geophysics is the study of the physical properties of the Earth and how they interact with each other. It's a field that combines aspects of physics, mathematics, and geology to explore what's beneath the surface of our planet. One of the primary tools used in geophysics is seismology. By measuring seismic waves, which are generated by earthquakes or man-made sources, scientists can determine the composition and structure of the Earth's interior. Seismology helps us to understand how the Earth's plates move and how earthquakes are generated. This information is critical for predicting and mitigating the impacts of natural disasters. Another tool used in geophysics is ground-penetrating radar. This technique uses electromagnetic waves to map out the subsurface layers of the Earth. Ground-penetrating radar is used in a wide range of applications, from finding buried archaeological sites to studying permafrost in the Arctic. Geophysicists also use computer modeling to simulate the behavior of the Earth's physical processes. This allows them to make predictions about everything from volcanic eruptions to the movement of groundwater. Geophysics is a fascinating and diverse field that can lead to a wide range of careers. From academia to industry, geophysicists are in high demand. So if you have a passion for the earth sciences and a love of problem solving, geophysics might just be the field for you. That's it for today.
And this simply general introduction about what is geophysics, and I will show case study from Egypt. Before starting showing this case study, I would like to ask a question: does geophysics play a part in archaeology prospecting? For sure, yes, geophysics play an important part in archaeology prospecting, and this proved by a lot of published scientific researches. And I will show now scientific paper published by cooperation of Geophysics Department, Faculty of Science, Cairo University, and Faculty of Archaeology, Cairo University. The topic of this scientific research is discovery of the tomb of the great army General Urahi using quasi-3D electrical resistivity tomography. Location of this study area in Saqqara, in Giza. Saqqara pyramids is the first pyramid was built in Egypt. It's represented as step pyramids, and this map, Giza location, and this Saqqara location, and this black box is area of study. In this area, 14 electric resistivity profile were measured, and by analyzing every line, we noticed the inverted ERT profiles show very high resistivity anomalies, more than 900 ohm per meters. Red colors mean resistivity 1024 is very high anomalies, which are seen on different profiles. These anomalies can be related to the underground cavities or crypts, and this surface remains, and this may be wall, this gallery between eastern and western holes. By looking in another lines, we noticed also very high resistivity anomalies on the surface. The interpretation of this resistivity lines shows the targets from this case study are the high resistivity anomalies with different ranges from 3 to 12 meters and depths ranging from 5 to 16. And these very high anomalies, it's represented like cave or room. We can from this map imagine the dimension of the room, and after that we make 3D contouring of iso-resistivity surfaces with different views for the study area, and after making 3D configuration for the tomb, we make comparison between resulted 3D representation of the inverted resistivities and the design of closed tomb in the area. As you see here, good correlation can be seen. Two main holes with corridor can be distinguished. A possible well maybe exist here in the eastern hole. After studying this area and interpretation, we drilled in this area, and this comparison between before excavation and after, we are found in these walls remains from the discovered buried site belongs to man, which called Urahi, who served in the period of Ramses II. This inscription of the walls of Urahi discovered tomb. When we compared this, we found this tomb was buried about 1290 BC, and this tomb now rejuvenated and updated to be the greatest tomb and represent as historical attraction for tourists in Egypt. For summarizing this case study, by applying one of the geophysical techniques, which called ERT, electrical resistivity techniques, researchers, geophysicists, and archaeologists have been able to map buried tomb and image the subsurface structure, and geophysics can contribute in enhancing the efficiency of archaeological exploration and increase our understanding of ancient Egypt history. And this my references that be used in this presentation. And thank you.
Projekt Fascynująca Ziemia jest finansowany ze środków budżetu państwa w ramach programu Ministra Edukacji i Nauki pod nazwą Nauka dla Społeczeństwa.